Hello friends, today we'll study material testing. Now, what is the material testing? Now, we have to test a material for various reasons. You have to find out the properties of the metal or the material that is to be used in industry before its manufacturing. Now, for that, we have to test the material. So, various types of tests are available. Now, we can see the mechanical testing. So, in this mechanical testing, the mechanical properties are find out from the test. Now we see there are two types. The material testing is broadly classified according to the two tests. That is a destructive test and non-destructive testing. Now destructive test name itself says that the material is tested by destructing the specimen. So the specimen whatever we are considering is totally destructed. Now, what is non-destructive testing? Where the materials are not destructed. So that is the two types. Now you can see the destructive testing requires destroying the specimen in order to measure the properties. Often requires a specially prepared specimen. Now this type of destructive testing are done before we can design any of the that component from that material. That means what are the metal is there, what we have to do, we are the main objective is to prepare a component, machinery component or the equipment from that metal. So before preparing that, we have to take a small piece of specimen, small piece of that metal from the that block, and we have to test we have to carry out the test on that specimen. Now in that test we have to destruct the specimen, so that is called as a destructive testing. Now we will see that the destructive testing are generally called as mechanical testing because we are finding out the mechanical properties of that specimen from the test. Now what are the mechanical properties? We have seen in the last video what are the mechanical properties. Now we can see there is a resilience, strength, stiffness, then hardness, toughness, fatigue, creep, ductility, malleability. All these types of properties are nothing but the mechanical properties of the metal. So we are calculating the mechanical property from destructive testing. Now you see non-destructive testing. It measures of the specimen without damaging it. Okay, and does not normally need to prepare a specimen. So we can carry out the test on the component also. So whatever the component we are preparing from that specimen, that metal block, we can directly carry out this type of destructive testing because there is no destructions are available. Now we can see they are used to find out the flaws in the part. Now what we can find here, the quality of the component. So for by using that non-destructive testing, we are finding out the quality of the test, those that quality of the component or the metal. The quality means there is what we have to find is the flaws. Flaws may be defects. There may be cracks. There may be density difference. There may be thickness difference. All these things we can calculate from the non-destructive testing. Now example is given X-ray testing and ultrasonic testing. So here in non-destructive testing, we are carrying out the specimen, the test, by using the various sophisticated uh, sophisticated techniques. So that is X-ray technique, ultrasonic testing. All these things are used. So these are the broadly two types of material testing technique. Now we go forward. So various types of destructive testings are available. Now we can see tensile test, then hardness test, impact test, grip test, fatigue test, other mechanical testing. So these are nothing but the destructive testing types of destructive testing. Now first we will see what is tensile test. You know what is tensile test? Tensile test is nothing but the test where we are taking a specimen, specially made specimen, and we are applying a tensile load on that specimen. So here we can see this is nothing but the specimen. So we are applying equal and opposite direction load on that specimen. So what will happen, the specimen will, if you apply a load on that equal and opposite, that is a tensile load, the length of that specimen will increase due to the tensile load. And after a certain time, when we are increasing the load continuous, if we are increasing the load, then it will go on, the line length will increase, then after certain time it will break at the center. So this is a tensile test. When we are applying a tensile load on the specimen, just we have to measure the various changes in that specimen and we have to record that. So it is called as a tensile testing. Now for that, specially made tensile testing is there. So it is called as a universal testing machine, where there is a provision that we can apply a load on the specimen, specially made specimen, and we can calculate the various types of property after that testing. Now this we can see that tensile tests are usually done on the specially prepared specimen. Narrow section is where stress is calculated, otherwise the specimen will break where it is gripped. Now neck occurs at the on ductile material after reaching the UTS, and cup and cone fracture indicates the ductility. Now we can see after the testing this type of breakage will be there of that specimen. So it is nothing but the photos of the specimen after testing. Now this we can see here cup and cake type of break that has happened. So they are generally due to the it indicates that the material, the specimen is ductile in nature. Now from that test also we have studied in the load and the elongation diagram. Now it says it shows various types of regions. So first thing it shows that there is a elastic deformation, then after elastic to plastic deposition, and this point necking starts. Then after certain time, if you go on increasing the load, then there will be fracture will occur. So this is the load extension diagram that we have studied in 12th syllabus also, where we can see when we take a specimen and we apply a load, tensile load on that, so the length will increase. So after applying, so when we are going on increasing the loads on that specimen, the first reason we get that it will apply elastic region will be seen. Now what is elastic region? Elastic region is nothing but when the load is applied and if we remove the load, what will happen? The change in the dimension will take place when we apply a load. When we remove that load, the specimen will regain its original shape, and that is nothing but the elasticity of the material. So this is up to here. The load will, the specimen will change the dimension after application of load, and if we remove the load, it will regain its original shape. Now at certain point, it after if we are go on increasing the load, again it will change. It will not regain its original shape, and it will convert it into the it will convert it into plastic region. So there will be a plastic deformation when it will not regain its original shape. It will, the length of that specimen will go on increasing, and at a certain point neck formation will start. And the material will be, after that if we next formation will start, and again if we increase the increase the load, then the fracture will occur. That is the different types of region we are getting. Now we can see up to here the uniform elongation is there, then there is a total elongation. Now here on x-axis we are seeing the elongation in mm and load in the kg on the y-axis. Now this can be also studied by drawing a stress and the strain diagram. Now here what we are doing, we instead of that elongation and the load application, we are considering the values of stress and the strain. Now we can see what is the stress and what is the strain. The stress is nothing but the load applied upon area, and similarly strain is nothing but the deformation of the component upon the original length of a component. So what is the stress then? Stress is nothing but from the formula itself, force applied upon load applied upon area. Now it can be also defined as that when we apply a load, when external force is applied on the body will try to resist this type of load, and this load resisting is called as a stress that is developed in the body, which will automatically oppose the force applied on that specimen. That is nothing but the stress, and the strain is called as a change in length upon original length, or change in dimension upon original dimension. So these are the two property we have to study that will be very useful in studying the mechanical property of a specimen. Now you can see stress may be direct, it may be shear, it may be torsional and leading or corresponding to deformation. Stress cannot be measured directly, but deformation can be measured. So these are the various types. Now you can see when we apply a load, or we can see the diagram, these are the nothing but the load. So if we apply equal and opposite direction, the length will increase. So how we can find out the stress? Load applied upon area, and strain change in length upon original length. So from the diagram we can see two types of load has been applied on the same specimen. What happens here? When we are applying a load equal and opposite on the specimen, the length will increase. So change in length is delta. So some change length will be there, and for stress, so from this diagram we can find out the two values, that is stress and the strain. Same thing if we apply a compressive load, that means equal and equal in the same direction, again the length will decrease. So from that this phenomena also we can calculate that these two property of stress and strain. Only the difference is that types of load is increasing, like types of loads are different here. When we apply tensile load, the length will increase, diameter will decrease. When we apply a compressive load, the length will decrease and diameter will increase. So correspondingly the value of stress and the strain will change when the loads are different. Now from this type there are types of stresses. Then tensile load. So when we are applying a tensile load equal and opposite direction, then there will be stresses will be developed in the body, and it is called as a tensile stresses. When we apply a compressive load, then stresses developed in the body is called as a compressive stresses. And when we are applying a shear, when we apply a shear loading, then the stresses developed is called as a shear stresses. Now what we can see here, say when the equal and opposite direction there is a tensile load is applied, stresses develop is called as a tensile stresses. Then again when same in direction, then compressive load, stresses develop is called as a compressive stresses. Now what is strain? What is shear then? The shear is nothing but the moving of the upper layer of a specimen on the lower layer. Now what will happen here if we apply a load like this? Tangentially we are applying a load on the specimen, then the upper layer of that specimen will try to slide on the lower layer. So what will happen here after application of load? So the specimen will look like this. So sliding of that specimen upper layer on the lower layer is taking place. So this type of movement is called as a shearing off, and the stresses developed at that point is called as a shear stress, and corresponding strain is called as a shear strain. So these are the types of stresses. Now we can see that after application of load we can plot each and every point at the loading. Okay, now we have to plot a one point. So when we are applying a load of 10 kg, then equal and opposite tensile loads we are applying. So we'll get value of some stress by the formula P by A, and we will plot that point on the graph. Correspondingly, we will get the value of strain. Likewise, we can go on increasing the load and we get this type of curve. So what this curve is saying that we can get a various types of regions or various points, and that point define the mechanical property of a material. Now we can see we can get a elongation, elastic region. This is all it is called as a plastic region. It is a elastic region. Now from that elastic region we can find out the Young's modulus or stiffness of a specimen. Then again we can find the strength of a specimen, how much it is the strength, and we can also find the ultimate tensile stress. Now ultimate tensile stress means nothing but the maximum allowable stress that the specimen can have in the plastic region. It is called as a UTS, ultimate tensile strength. After that the necking will start and we get the breaking of that. So stress at which the metal fracture is called as a fracture stress, and the maximum allowable stress in the plastic region is called as a ultimate tensile stress. Again various elastic stress will be there, proportional stress will be there. These all the properties we get from the tensile test on the specimen in the stress strain curve diagram. Now we can say one more thing. From the load extension diagram, what we get is the yield, then the UTS is nothing but ultimate tensile stress, breaking, fracture, elasticity, plasticity, and necking at that point. So when we get after application of load, we get elastic region, plastic region, then the breaking region. Necking start after that necking region which we get. So from the load and extension diagram we can find out this type of properties of a metal. Now from the stress strain curve, what we get the different values of a stresses. Now we can say from the diagram, it is here stress value is there and here the strain value here. Now from the diagram we are getting the value. So this much you can see, this much is the elastic region of that specimen. Then whole behavior, it is called as a plastic behavior. Then from the this we get the first point is the ultimate stress, then fracture stress, then here is the yield stress, then here is the elastic limit and proportional limit. So what we get various values of the stress. So first is the stress of ultimate stress, then fracture stress, then yield stress and proportionality limit. Now what we can see from this, can find out the ultimate stress, that means how much the material can be stressed within a plastic region. That is a mechanical property. Then fracture stress, so at what stress value the material will fracture. The what is yield stress? The use of yield stress, that it shows that at what point of stress the material is converted from elastic region to plastic region. And proportional limit, that means at what point the graph is showing a linear behavior, that means stress is directly proportional. So that is nothing but the proportional limit. So these are all the values that can be calculated from the that stress strain curve diagram. Now from that again one more thing we can find out is the area under the elastic region is called as the stiffness of that specimen. Area under the curve up to ultimate tensile stress is called as the hardness. Now what is hardness? We have seen a material, the ability of material is called as ability of material to resist all deformation is called as a hardness. So area under the curve up to ultimate stress is called as a hardness. Then area under the whole curve from elastic and plastic region up to breaking is called as a toughness. Now what is toughness? Toughness is nothing but ability of material to break before its ability of material to absorb the force before its fracture. So area under the whole stress strain core is called as the toughness of that material. So this is all the properties we can calculate from the stress strain curve. So that is the use of that stress strain curve, and we get that stress strain curve from the tensile testing machine. Now you can see different graphs of the stress strain curve. Now here the stress is carried out, test is carried on the mild steel. The mild steel will show this type of curve after the test. Then you can see the stress strain curve for various types of material. Now for here we can see different metal specimen are have different stress strain curve. Now the important property here we can see magnesium. It will give a this type of curve. That means there is only very less elastic region is present in that aluminum. Sorry, magnesium. Then we can see aluminum sheet, that is non-ferrous metal. This type of curve will be there. Small elastic region and plastic region. Again, anneal alloy steel. So this type of curve will be there. So each metal will show different types of curve. Now we can see nickel alloy steel. Again, it is having maximum elastic region and very less plastic region. Again, you can see from the diagram, it is a mild steel. That means mild steel is very ductile in nature. So this type of curve can be possible. Again, here the water and quenched. So these are various types of curve we get after application of load. So we will get a different value of ultimate tensile stress, yield stress, proportional limit. Then elastic region will be different for different material. Plastic region will be different from the different material. Breaking stress will be different for different material. Then again, ultimate tensile stress will be different for different material. So from that curve we can find out the mechanical property. So this is all what we can say is the tensile testing machine. Okay, this is all we can see today. So thank you friends for listening me.